Good morning, afternoon, everybody. This is Lynn Rubenstein. I'm the Executive Director of the Northeast Recycling Council. And with me this afternoon, we have Terry Goldberg, who's the Executive Director of the Northeast Waste Management Officials Association, NMOA. And we also have our speakers, Deb Darby from Tetra Tech, Brian Paganini from BioPower, and John Hasselman from Vanguard Renewable. Before we get going, I just want to do a tiny bit of housekeeping, and then we'll actually get to the good stuff. So first of all, this webinar is being brought to you jointly by NERC and NMOA, and hopefully you realize it's about depackaging and commercial composting, an integrated system for organics recycling. We do have two great sponsors, ADS and Vanguard, and thank you so much to them. I want to point out that this webinar is being recorded, and the recording will be available on the NERC homepage by tomorrow. You'll get an email to that effect as well from GoToWebinar. So the important part, apart from the presenters, is that you ask questions. We really do want your questions, and we'll be asking the questions at the end of all three presentations, but ask them while we go. So to find it, if you're not familiar, on the right-hand side of your computer monitor, either you see the full GoToWebinar dashboard, or you have a little orange arrow. So if you don't see the dashboard, click on the arrow, and it will open the dashboard. Otherwise, it's there. Find the little questions tab, open it. There's a little arrow, you click on that, and then you type your question into the question box and hit return. And Terry and I will secretly see them behind the scenes. And as I said, we'll ask them at the end of the presentations. So with that, I'm really looking forward to hearing from our presenters. Our first speaker will be Deborah Darby. She is a manager of organic sustainability solutions with Tetra Tech, an engineering and environmental consulting firm with a focus on solid waste and organics. As part of Tetra Tech's solid waste solutions team, she is involved with solid waste master planning, permitting, and the operations of organics management systems. She has 14 years of organics experience within the solid waste industry and is a certified composting professional. Deb holds a master's degree in cleaner production and pollution prevention from the University of Massachusetts Lowell. Following Deb will be Brian Paganini. He joined Quantum Biopower in 2013 as Vice President and Managing Director. The Quantum team has built and are operating the first food waste to energy plant in New England, diverting food waste from traditional landfill and creating renewable energy. As Vice President, he has led the creation of new energy legislation in Connecticut and has developed food waste recycling infrastructure that recycles food waste into valuable products such as natural gas, electricity, and compost. Brian led the creation of Quantum's complementary service offering for companies and municipalities seeking to divert food waste. Prior to launching Quantum, he was a graduate of the University of Connecticut School of Business and is an active alumni. And last, but certainly not least, is John Hasselman, co-founder, chair, and CEO of Vanguard Renewables, one of the largest recyclers of food waste in the US. His focus is developing organic waste and decarbonization solutions for food manufacturers, corporations, and retailers, and enhancing regenerative agricultural practices alongside Vanguard's farm partners. John has more than 30 years of experience leading renewable energy, environmental, emission-driven companies. So thank you, folks. Really looking forward to this. Deb, I'm going to make you the presenter, and then we will be able to enjoy your presentation. Thank you.
Okay. Let's see how this works here. I am waiting for that that sign, right?
Yeah. Yes.
There we go. I'm getting that.
Great. Thank you.
I am going to share my screen now. So you should see my first slide. Thank you so much. So first of all, I just want to tell you how excited I am to be part of this webinar today. Following my short presentation are our two other excellent presenters. So this is a topic that I love talking about, organics management, and this is on depackaging and commercial composting. So let me get started here. Thank you. So in the late 1890s, recycling as we know it didn't exist, but people were way better at it. So like if a dress went out of style, you added new buttons, old fabric would be turned into a quilt, or the rag collector would come by and barter. Bones and fat were used to make fuels and soaps. And food was just tossed outside windows as to feed animals. So of course this wasn't sanitary, and cities implemented sanitation services to manage solid waste. I'm obviously simplifying the journey here, but I just want to take us to how paradigm shifts in solid waste management have occurred over time. More recently, landfilling and waste to energy have been long-term, cost-effective, and environmentally compliant solutions for the management of waste. And while we continue to have these waste solutions, our paradigm for materials management continues to evolve as markets shift and new technologies become available, allowing us to realize an even greater or larger fraction of value from resources that are discarded, bringing us to a more circular infrastructure and economy. And organics is the next solid waste commodity. So the US EPA recently updated their 2018 Advancing Sustainable Materials Report in November of 2020. And I just want to touch on a few facts. Americans generated 292 million tons of trash. And of that trash, the organics fraction, food waste was 21.6%, and yard trimmings, yard debris, was 12.1%. The EPA also reports that the commercial, institutional, and residential sectors generated 63 million tons of food waste. When we look at the management of waste, only 25 million tons, or 8.5% of materials, were composted. In addition, 18 million tons, or 6.1% of wasted food, was processed through other food management pathways, including donation, animal feed, land application, co-digestion with AD, sewer, wastewater treatment, and bio-based materials, chemical processing. And in 2018, the EPA included these 6 pathways to capture the flow of excess food and waste through the food system. So this trend in managing food waste opens opportunities for organics involving the collection, pre-processing, and management of materials for these additional pathways. Still, I do like to point out there is a significant amount of food waste that remains trapped in the municipal solid waste stream. I also would like to point out that the solid waste infrastructure requires a portfolio of organics management systems, including more composting systems, as there is a significant need for compost as soil amendment products for beneficial use and human and environmental health reasons. And I'm happy to discuss that topic at another time, if that's okay. Legislation is really a key driver of organics management and the need for organics infrastructure. As of December 2020, there were 21 states with yard debris bans from disposal in landfills, and 4 of these states have exemptions for landfill with gas collection systems. These are Florida, Georgia, Iowa, and Nebraska. 8 states have an organics recycling mandate or legislation for diverting food scraps from landfills, with New Jersey being the most recent state to adopt a food waste diversion plan. And certainly as states and municipalities aim to implement zero waste strategies, organics is one of the primary materials to divert from the solid waste stream. Even for locations that have addressed recycling or made other progress, organics often are a largely untapped area. And throughout our Northeast region, regulations are focused on diverting organics from landfill, with the target being commercial generators, except for the state of Vermont that has a universal recycling law that includes all food waste, residential is included. And with our problem of decreasing waste disposal capacity and increasing costs, both the public and private solid waste facilities are looking for ways to divert organics and be more compliant with these emerging commercial organics bans. And so we see a growing need for managing food waste from the industrial, commercial, institutional, or the ICI sector. Commercial generators must separate their food waste and unsold food products from their solid waste stream. So the need for collection and depackaging food products is evolving. And depackaging solutions respond to this need and are designed to remove the outer packaging and remove the food from its primary packaging with a focus on the reuse of the food as well as the packaging materials. And this certainly can open up opportunities for solid waste facilities to get involved in organics management. Depackaging operations can be a standalone facility as well as tie in closely with existing material management streams such as MRFs and transfer facilities. So depackaging, what's its role? It's a pre-processing step. It eliminates the need for manual labor and helps eliminate waste. It's difficult for commercial generators to source separated food for many reasons, like employee turnover, training, lack of space, time consuming to open up product and packaging, the yuck factor, are just to name a few. But depackaging helps keep contaminants out of the feedstocks that are aimed for wet anaerobic digestion systems, where food waste slurries can be pumped into wet AD systems. Depackaging can also pre-process feedstocks aimed for composting operations, where the food waste particle size can be reduced for mixing with other feedstocks. So it minimizes the contaminants entering organics recycling facilities that can take in commingled source separated food waste from the commercial sector, as well as residential organics diversion programs. And depackagers can average between 90 and 99% recovery rate, depending on how much food remains adhered to the packaging after separation. So what I find very cool, of course, is the process itself. It needs to be designed for the right application. And in essence, there are two streams of materials that need to be managed. For example, are you going to be targeting food waste, or are you targeting the packaging waste, the cardboard, plastics, and metal? So depackaging operations can be optimized to target organics for wet AD, as well as composting with minimal contamination and do as little damage to the packaging material for recycling purposes. Just a couple of examples. Here's some, produce boxes, and this image just really kind of shows how the packaging itself, is in really good shape and clean for recycling. This next image here actually shows the two waste streams. You've got your organics and you got your packaging after the separation process. And the organic stream looks very clean, as well as the packaging waste also looks clean for recycling. So how depackaging works? Let me just start with, there are both American and European companies that offer depackaging equipment to the US market, and many are focused on the anaerobic digestion industry to make contaminant-free food waste slurries that can be pumped into wet digesters. And nearly all packaging is considered a contaminant, including compostable, I should say certified compostable products, film wrappers, and bags. So it's removing the pre-consumer food or liquid from its packaging, which is the separation process. And as I mentioned a little earlier, there's two product streams. You got the organics material and you got the packaging. And these systems are modular and they can be based on customer needs. Systems can handle small to large volumes, I believe up to 200 tons per day, but I bet our next two speakers can speak more about that. But just as one example, this is a quick overview of the main components of a Depack. A shows the in-feed conveyor with the blue arrow showing the direction of the flow of the incoming packaged food. B shows the in-feed screws that enabled in metered flow of the materials entering C, which is the separator device. And then D and E show the different pathways for the packaging waste and organics being discharged. And again, this is a one specific model, and I'm just using this as an example to show the basics of depackaging. So integrating organics management into existing solid waste facilities or as a standalone operation really requires understanding of the market, from feasibility studies, analyzing feedstocks, beneficial end-use markets, through designing your system layout. All of this will drive the engineering concepts and implementation of organics recycling or other types of organics management systems. And this is exactly the type of work that Tetra Tech can do for any site and client. And this is just one example of a tool that I like to share with clients just to help visualize the potential flow of feedstocks. Clients like to walk through this flow chart to understand feedstocks, different types of technologies, and how material can flow through systems, produce products for the right end-use markets. And then in closing, I always like to give a kind of a Deborah Darby perspective. There's a growing interest in developing organics infrastructure. Private and public entities need to collaborate to pivot public thinking around and toward a circular economy and a more sustainable flow of materials. And this involves changes in public behavior in terms of consumption and disposal, where food waste is recycled back into the market with high value use through composting and anaerobic digestion. And there's many considerations in the planning, development, and operation of organics management facilities. These include siting, state and municipal regulations, permitting, available feedstocks, and population density and commercial demographics surrounding neighborhoods and businesses. All of these factors provide meaningful data in determining what type of an organics project is needed to service an area. And certainly most projects are scalable when they're designed properly. So I want to thank you very much. And Lynn, please let me toss it back to you.
Thanks, Deb. That was tremendous. And of course, we are receiving a lot of questions. And they're extremely interesting questions. And if it wasn't for the fact that I said we were going to hold questions, I'd be asking you questions. So let's just say that. I am noting the questions. We'll get to them towards the end. Brian, let's see. I can see your presentation, and thank you so much. And I'm looking forward to it.
Lynn, thank you so much, and Deb, thanks for the handoff. My name is Brian Paganini, and I don't want to go through the introduction again because Lynn did it so eloquently. But many thanks to you, Lynn and Nurk and Numo and Terry, and obviously ADS and John at Vanguard for supporting this presentation today. As you can see on the screen in front of you, we're going to talk a little bit today about depackaging and commercial composting. And if I can get the slide to change, there we go, successful. So this is a picture of what I normally look like. I'll apologize for the bruise over my right eye. I've got an 8-year-old son who sometimes thinks he's Hulk Hogan. So again, apologies for the bruise, but enough about me and about Quantum and here at Supreme. So we're having an important conversation today, and one that many of you are having with your municipality, with your private company, about how to harvest the good things from our waste stream. And how do we do that in a manner that is consistent with environmental goals and also maybe saving a couple dollars along the way. And what I'm going to do today is kind of take you through Quantum and Supreme story and how depackaging has impacted this conversation, because it's a topic that is very core to our business. And frankly, organic waste recycling is our business. Our mission is very simple. We harvest organic materials from waste and create a variety of products, whether it's energy or compost-based products, just using our process and know-how. In a lot of ways, we look at organic waste much similar to the show Gold Rush. It's a popular show in the Paganini household, and there's a lot of guys who are working hard to harvest good stuff out of the ground, mixed in with soil and rock, and trying to create value, right? We look at food waste and organic waste substrates the same way. Food waste and organic waste comes in many shapes and sizes. It's usually commingled with other waste. And whether it's in packaging or in other types of wrapping, it's our job, and we've made it our job to harvest those waste streams from packaged goods. And we feel at Quantum we are one of those such groups. So a little bit about our experience. We've been in the organic waste recycling business for roughly 40 years. We process 40,000 tons of food waste at our anaerobic digester, which we'll talk about, and roughly 300,000 tons a year of green waste materials, including stumps, brush, leaves, and wood. We've got roughly 2,000 customers stretched out across the Northeast footprint who are consumers of a lot of the materials that we make at one of our yards. Speaking about the right team, we feel as though we've got a really good team of 300 team members who are mostly scattered throughout the Northeast, but primarily located at one of 3 of our volume reduction centers here in the state of Connecticut, helping to process and recycle the variety of organic substrates that come down the road. We always joke we probably have more equipment than manpower, so talking about depackaging equipment is right in our wheelhouse. We certainly have our fair share of experience with equipment, and depackagers certainly foot that bill. And at the end of the day, we raise our hand and recognize that it's the partnerships that really drive the bus for us, whether it's our municipal partnerships or our private partnerships. We're a company that relishes those partnerships because we believe that the ideal goal for all of our customers and partners is to have a win-win situation. And part of what we do at Quantum has certainly invoked that. So being organic waste recyclers, in 2015, we set out to develop what amounted to one of the first industrial scale food waste digesters in the state of Connecticut. This facility processes roughly 40,000 tons per year, making a little over 1.2 megawatts of renewable class 1 power, diverting roughly 5,000 tons of CO2 by recycling methane and creating compost at the outset. To give you a bit of some scale about this facility, the tank you see in the backdrop, roughly 60 feet tall by 40 some odd feet wide. The operations building in front of you is 120 by 60. The facility is fairly inaudible from 50 feet away, and there are no fugitive odor emissions. We have a pretty sophisticated air capturing system inside the plant. And this was all part of the design process to show that we can site critical food waste infrastructure in areas of population density. And there's a lot of deliberation. We worked very hard to keep this a clean facility and to demonstrate that you can recycle food waste in a very clean manner. The digester is part of a larger organics campus that we call an eco park, located in Southington, Connecticut. Most of this land is privately owned by us, but 20 of these acres is sited on top of our community's local expired landfill, where we manage our community's leaves in exchange for operating on the landfill space. There's digestion operations obviously happening, composting operations. We're receiving a myriad of food type waste products, which we'll talk about. There's composting on site, and we're producing biogas, electricity, mulch, compost, and soil at the outset. We've also have about a megawatt of solar on this facility, and we're preparing to bring in some storage capacity for electricity in 2021. A few years ago, we began operation of a green waste recycling center in the town of West Hartford. Much of a similar arrangement. We manage all of the town's local green waste needs and then help them to reimagine this site actually this year. And we're planning on building a new waste processing center at the end of this year, which will have more sorts of diversion equipment such as depackaging, also some fueling stations and other renewables integration. And our final site is in Harlingen, Connecticut, in Northwest Connecticut, where we are processing a lot of forms of green waste that we turn mostly into mulch and other products. So in talking about this decentralized waste approach and building this sort of hub and spoke concept around managing organics, our business is quite simple. We're taking in pre and post consumer waste streams, things that have not been consumed, food waste materials that have been consumed and maybe scraped off of a plate, food waste materials that come from packaged goods. We also have a pretty healthy intake of green waste materials. We're processing these materials on a variety of our sites, and we're producing soils and biogas and mulches and compost. And those materials are being received and transacted with a number of our customers. We sell all of our electricity from the digester through Eversource to our host community, who gets the benefit of our power. We're powering our community's wastewater treatment plants, their municipal building, their fire station and police station. And if you've bought a bag of Scott's mulch or bought a bag of mulch from Walmart or Agway in the Northeast, odds are some of our material is in that bag. So in the world of reuse, this is probably the part of the picture that we're most excited about. It is this whole story about harvesting nutrients from organic substrates like food waste, and then turning those materials into organic compost blends. We took a pretty substantive step in 2019 to that end and launched a product called Nutragrow, which essentially takes a lot of the solids from our digestion process, blends it with other ingredients such as biochar, leaf and yard waste compost, and other materials that go into the secret sauce, if you will. And we finish compost that aerobically. And the majority of that material ends up getting bagged, and we sell those bags into the marketplace, into the retail space. Last year we did about a little over 1 million bags. This year we're on pace to do about 2 million bags. So for us, we see the value in the future in harvesting those nutrients from food waste streams. Thankfully, we have some really smart academic partners in our state. So we undertook about an 18-month endeavor with the Southern Connecticut State University Agronomy Lab, and we were able to demonstrate some real results around using organically driven nutrients in a compost blend. What we found was that we found stronger crop yields when using organic compost. We found stronger plant rooting and vigor. And when you use other materials that harness nutrients, other ingredients in compost blends that also can keep hydration within a soil, we found that compost was less susceptible to drought and also delayed nutrient uptake, almost created this delayed nutrient onset for creating more plant growth. So we're very excited about the future of organic soils and how that sort of plays in unleashing those nutrients from food waste through a digestion process. So now we're applying a lot of that learning back into the food waste space. We've got all this carbon and nitrogen, and when we put these things together, we make a really great compost blend. What we've learned is that when you look at the digestion process, it's great to make biogas, but we're also looking at ways of getting those nutrients in a more readily available fashion. So just to give you an example, about 700 pounds of nitrogen is produced from our digester on a daily basis. And that's nitrogen that could be used in a compost blend and brought back into the growing cycle to help support future growing within the state and within the Northeast region. So the question is begged, what does this have to do with depackaging? We're going to get to that point because what we're finding is that in 2014, when we sought to develop this project and this digester, we had a vision for what food waste was and what food waste could be. That vision dramatically changed over time. And what we're finding is that there's a disproportionate amount of what we call unconventional food waste in the marketplace. And unconventional food waste is food waste that might come in packaging, difficult to recover organics, high strength food waste, or other non-traditional food waste streams. Again, in the mode of learning as the market is evolving, as I'm sure you all are learning as the food waste market is evolving in your geography, this was a big learning for us. And it was important for us that as we started to trend towards looking to not only make biogas from food waste, but harness those nutrients, that we changed accordingly. So we spent a lot of time in the past several years developing algorithms and developing processes that categorizes and catalogs food waste, because not all food waste is created equal, whether it's a can of Campbell's soup or a bag of romaine lettuce. There's different energy content and nutrients in these substrates. And if our goal is to make good biogas through our digestion process, keep our digester healthy and strong, but also recover the nutrients from food waste, then it's important to know what's going into this process. So we've spent a lot of time going through that process. And obviously, looking at unconventional waste, we tried to now apply process technologies such as depackaging and organics recycling to that end. And we're going to give this a shot. I can't guarantee this is going to work, but this is a short video that we've created about our depackaging facility. You can see that this facility is adjacent to our anaerobic digester in Sullyton, Connecticut. All the energy utilized from this facility in our organics recycling center comes from an anaerobic digester that's located on campus. We have 6 drive-up loading docks for folks to drop off material. And as you can see, there's a variety of material that comes into this facility, whether it's in a bottle or it's in a can or it's in a piece of packaging. We have the ability to offload those materials in a very short amount of time. And simply all we're doing at this facility is we're separating food waste streams from their packaging, recycling the food waste that gets sent into our anaerobic digester, which is roughly 100 feet away, and then recycling as much as the packaging as we can to make sure that we're minimizing the residual materials that are created from this process, such as packaging and such as cardboard and aluminum and plastics. As you can see, a bale of plastic sort of running by the screen right now, and doing our best to create this comprehensive recycling process here at Quantum. So I hope that showed up a little bit on your end. We'll see. Okay. All right, next slide. There we go. Okay. So just to give you the quick rundown on how we're looking at depackaging, we take a variety of trucks here at the facility. It could be tanker trucks, tractor trailers, could be traditional rear pack garbage trucks. We're taking in a variety of organic substrates, whether that's in a compostable bag or in a package. We're recycling those materials, separating the food waste. The food waste is going to digestion on our campus, and we're recovering as much as the recyclable materials as we can in the form of cardboard, plastic, or aluminum, and then bringing those materials back into the recycling marketplace. And what that looks like from a municipal perspective is, obviously, as you all know, we're all aware, diversion goals and disposal pricing are rising, right? Disposal capacity in certain geographies is decreasing. The recycling markets are depressed. And as we create these decentralized means of recycling food waste and other unconventional waste streams, we're helping to kind of shore that gap between what's really happening in recycling and what some of the diversion goals are in a given state. On the private side, what's happening is roughly 80% of Fortune 500 companies have sustainable development goals. But as we know, only about 20% of those companies are making meaningful progress towards those goals. So if we can offer a solution as a company to the folks who are trying to do better at recycling those materials, those organic materials, using a process like we have in an EcoHub or an EcoPark campus, then we're helping private customers, like some of the folks you saw mentioned, achieve those sustainable development goals. So really a public and a private benefit through one facility. And it's our commitment to whomever we engage with our partners that we're always trying to track and report back sustainability metrics, whether that's quarterly or yearly. We're always trying to report progress back to our customers to let them know that how they're doing, how their diversion rates are achieving, what their efficacy rates are, and the environmental impacts of diversions per customer. So looking forward a little bit, just giving some forward thought here. I mean, everyone has probably seen the opportunity for biogas in North America. You know, these numbers might be a little off, but let's just say that there's a large opportunity for future biogas. We're committed to 4 things as we move into 2021. First and foremost, it's continue to partner with both public and private partners out there to develop and install infrastructure to help recycle a myriad of organic substrates. Secondly, it's trying to create mutual benefit for partners, particularly in the municipal space, as we're trying to figure out what this next iteration of waste recovery looks like. And there's no one size fits all. And it takes a nimble and well-formed group to help solve these unique challenges depending on where you go and what municipality you tread into. And we're always trying to grow our capabilities, looking at more difficult to treat organic substrates to harvest those nutrients, such as high strength wastewater, high strength organic waste streams, and also municipal wastewater solids is on the horizon as well. And then finally, we're always doing our best to continue to develop post-digestion processes that create better soils, create better nutrients, and create better materials, so we can complete that circle of nutrient recovery as well as biogas production through our digester installations. So again, I thank you for your time today. Thank you for being patient here and being attentive, and I'll throw it back to you, Lynn.
Thanks so much, Brian. That was great. And I'm going to make John, and there are lots of questions, which is excellent news. So I'm going to encourage our audience to keep them coming. And John, you should be the presenter now, and it looks like you are. Excellent. Thank you, John.
All right. Thank you, Lynn, and thank you, Brian and Deb. I think all of us have come to the same conclusion that food waste is something that is absolutely critical that we recycle, and that we have the chance to put it to beneficial use. We're always stunned, I think, at Vanguard Renewables about the power of food waste, either for good or for bad. What's remarkable about food waste is that it can be a really awful producer of really corrosive greenhouse gases, or you can use it as a way of creating this wonderful virtual circle that Brian was talking about and Deb was talking about, and creating some really important and critical components of what we believe are going to be the future of climate reduction, not just in New England, but throughout all of the United States.
John, I'm sorry to interrupt you. If you're able, could you pop that into slideshow view?
You bet.
Thank you.
There we go. Thanks, Lynn. So I think, as Brian and Deb kind of talked about how we do the voodoo that we do, I'm going to try and talk a little bit about, just in the beginning, as to why we think it's so important and critical, not only just at the commercial level, but at the institutional and municipal level, as why recycling food waste is going to be something that we see as being really something that everyone should be participating in across the US. So I think everyone knows that there is a real concern with food waste. I don't imagine that most folks understand that really 40% of all America's waste is organic materials. One of my favorite factoids is that if food waste were a nation, it would be the third highest greenhouse gas emitter behind China and the United States. And the reason for that is the second factor, which I think most people aren't aware of, which is as food waste breaks down, it emits methane, which is 40 times more corrosive than CO2 as a greenhouse gas. And being able to capture that methane and actually repurpose it as renewable natural gas is an incredible change in the carbon footprint of food waste as it stands. So it can either be something really damaging to the environment or something quite beneficial as a tool to decarbonize and replace traditional natural gas with renewable natural gas. And that's something we're working on across our portfolio, and we'll talk about a little bit more in a minute. What I think is critical is understanding that this actually can be done at scale. When we started the company back in 2013, we had spent a bunch of time looking at Europe, the UK, and Canada, which are candidly a decade to 2 decades ahead of us in recycling food waste. And it would be unheard of if you were in a German household that you would throw your food waste into the trash. That's something that just is inconceivable to them. And it's a goal that we hope we can achieve here in the US, that same recognition of the value of food waste. And for us, first and foremost, it's recycling it and sequestering that methane. But the second part is being able to work with farms. And so all of our food waste ends up, it may start in many different forms, but it ends up on a farm. and being able to use it first to remove that gas and put that back into constructive use, but then also to take the byproducts. And Brian has shown a couple of models as to how they can use it in fertilizers. We use it as organic fertilizer for all of our farms as well. And the ability to return those nutrients that otherwise would end up in a landfill or an incinerator, but take those nutrients and then redeliver them to the soil where they came from, is something that we see as just the most important circularity that we can bring to the American agricultural system and to all of the food manufacturing partners that we have out there in the US. We did start really with that intent. We've been excited to be able to now have 6 different facilities across New England. We're in Massachusetts and Vermont. We've built our 7th facility, which is our depackaging facility in Agawam, Mass. We're now receiving organic materials from all across New England and New York, and are delighted to be able to take that product, whether it's in any form that's coming, extract that gas and really capture all the potential value that's there. I think it's critical to understand the flow, and Brian showed this in one of his slides, and I'll dig a little deeper from where we are. The learning that we've had over the past 7 or 8 years is that food waste comes in many, many different forms. So it can be out of commercial large customers, it can come out of institutional customers, but really only about 20% of it, and actually not even 20%, about 17 by Mass DEP standards, is clean. And it's something that can go immediately into the digesters at the farms. About 80% of what's out there is somehow it's either packaged or contaminated. That being it's been commingled with other inorganic materials that aren't appropriate for digestion and for fertilizers. So you've got to be able to handle all of that 80% as well as that 20%, the clean stuff. And so like Brian, we decided that we needed to have a depackaging facility, an organic recycling facility, which really acts almost as an organic transfer station. So we take food waste, collect it at the generator sites in any different form. We can take it on pallets, we can take it in roll-offs, compactors, totes. We've got lots of customers who've got actual containment facilities on site where we'll come and pump those out. We then take it, if it's clean, if it is that 20% clean material, we'll take that directly to the farms. If it isn't clean, it goes to the depackaging facility. And there, I think as Deb and Brian said, we have some really outstanding technologies. Ours are primarily American. I think we're using a lot of the same technologies that Brian and the team are running. And there we're able to separate those materials, recover the recyclables, and send the rest up to the farms for digestion. What's so important to us in the digester side of it is closing that circular loop. So if we can take a pint of off-spec ice cream, extract the gas from that, send that back to the factory that has made the ice cream, then take the lovely fertilizer that comes out, the wonderful organics that come out of the back, bring that back to the farm, grow the hay and corn and alfalfa that we feed to our cows, and then deliver that milk from the cows back to the ice cream manufacturer. That for us is something that's really unique in the United States. But it doesn't have to be. It's something that we think should be commonplace. And if you look at what has occurred in Europe over and over again, and in the UK, that circular energy loop, that circular nutrient loop is something that it's a daily occurrence. And we believe that the way to empower that is making it easy and simple for any municipality, for any institution, for any commercial food manufacturer to take that food waste and put it back into beneficial reuse. What we see, and I think Deb talked about the yuck factor, I would agree with her completely. It is daunting to see 700 tons of food waste, which is what we collect about a day in New England. But it's remarkable to us. I think, paraphrasing it, it smells like money. But it is something that is really, really important to be able to give anyone who wants to participate in food waste recycling and in organics recycling the ability to do it and remove the barriers. And what I think has traditionally been the biggest barrier is contamination in packaging. And so having these depackaging facilities, having the organics recycling facility available to customers, and this is our first one. We built in Agawam, but we will be building many more of them across New England and throughout the US. I think that is the key enabler that allows this industry to really grow at scale. That is my presentation.
Thank you, John and Deb and Brian, really tremendous. I am going to take it away from you. If everybody could put their cameras back on. I have to remember to do that too. That would be great. As I said, we've had a number of questions, and they're all fascinating questions. And so I'm going to start with some that are really just at the basics. There were several people who were fairly horrified by the amount of food. And John, I have to admit, I laughed out loud when you said it smells like money. But so, some people have asked literally, what is going on here? Why is there so much? And then there was also, the corollary to that is, why isn't this food being donated? I mean, why not as a slur on your operations, but that's not really the highest and best use. So why is this happening? So I think we want to hear from both of you, please.
Yeah, and I'll take a first shot, and then Brian can dive in, because I think we both feel incredibly strongly, and I think the same. And knowing Brian well, I think we are of similar mind on this one. So we don't take food that could be donated ever. All of the food that we take is unusable food. It's unsafe. So it has lost temperature if it was refrigerated and has gone off spec. If it is out of date and potentially toxic, that's the food waste that we get. So we don't take, we're very strict, and the EPA has got a lovely hierarchy of food reuse. And first and foremost, usable food should go to people in need. And we actually, earlier in the beginning of the pandemic, created a whole program. We started seeing raw milk and unprocessed milk coming into our depackaging facility and into our digesters. And we actually reached out to the Dairy Farmers of America, who are wonderful partners of ours going back to 2016. And we created a Farmers Feeding Family joint venture where we could actually get that milk back into communities and not take it into our systems. And I think Brian and Deb are probably of like mind, which is we don't want to take anything that could be consumed by humans or even consumed by animals. And so we're taking the unusable food waste. But even that, again, is a huge volume in the United States. We have an abundance since the Depression and since World War II. America made a decision that we will never be hungry again. There's a lot of distribution issues and stuff that we're all working on to make that abundance, to make sure it gets to everyone. But there is an enormous quantity of food that's available, unusable food that's available to us. And I don't know if Brian wants to jump in.
Yeah, no, I think it's well said, John. And I know you share this perspective on food waste. I think the way that John and I look at food waste in the waste shed in New England is our facilities are really the last line of defense in recycling, right? We always prefer that food get consumed by animals and by humans well before it arrives at our facility. And we've got some wonderful partnerships with our donation centers in Connecticut, and oftentimes we find ourselves lightly asking the question of some of our customers to say, hey, you know, does this make sense to have it be diverted towards donation? We've got a recovery center up the road from us that will take in food from grocery stores and from distribution centers, and when that food expires or is unsellable or is not able to be consumed, we'll then take that material in. But what we find is that, and this is, we take cues from the European countries, is that as folks are more aware of food donation, food recycling actually increases because the culture of food recycling and food waste rises. So again, working off of the basis of we're the last line of defense when it comes to food waste and food recovery, and that's the position that we've taken. I know John shares that opinion with his facilities as well throughout his processes.
Great, thank you. So I'm going to, and I want to stress that there are a lot of questions here, and I'm trying to consolidate and, hit as many topics as once as I can.
That's the good news.
Yeah. So several people have brought up in one way or another the question of, we're told that the food in containers is contamination, that wet cardboard can't be recycled, that basically the process that you are describing renders packaging non-recyclable, and yet we're hearing from you that you are recycling it. So what's up?
Better technology.
Right. Better technology, right? Yeah. That's what it comes down to.
Yeah, and Brian, you go ahead and you start this one.
Sure. Okay. So I'll take it two ways. Let's talk about the cardboard piece. There's a variety of levels of cardboard, right? So if I'm buying a 6-pack of yogurt at the grocery store, there's a thin cardboard wrapper around my yogurt containers. And when it comes to my facility, it's wrapped in an overpack box. So we're doing our best, and we do recover that overpack box, and that material gets pushed aside, and we're baling that cardboard and sending it off for recycling. The cardboard that is around the yogurt containers does make its way into the digester, and cardboard, when it breaks down, sort of ends up as this lignin material that actually ends up in the solids fraction of our digestate, of our post-residual digestion products, and that makes its way into a compost blend. And anyone that knows, when you're taking wet cardboard and putting it into a compost pile and properly conducting aerobic composting, it really makes a tremendous bulking agent or substrate for a compost blend. So whether we're covering it on the pre-processing side or through the digestion phase, it's being recovered in some fashion. Again, trying to minimize the amount of residuals going through the depackaging process and ending up through the digester. But in no matter what, we're doing our best to recover most of it.
Great. And John, did you want to add anything further to that?
I think Brian kind of hit the nail on the head, which is it's really, our goal, the technology, when you're told that you can't recycle a plastic bin, a yogurt cup, because it's got yogurt in it, for us, that's actually the dream come true. We wash that yogurt out. So we do what my teenagers won't do, which is wash out the yogurt cup before they recycle it. We've got the machinery to actually do that. So,
and of course, MRFs don't do that. So that's it's a different technology.
MRFs do not do that. Yeah, and that's why we're ORFs and not MRFs.
Okay. So, and the next question, I'm going to think that Deb might be the right person to respond, but who knows? Several questions relate to concerns about microplastics. So, through your process, some of the questions seem to presume that there's a risk of microplastics being produced. I don't know if that's a valid concern, so that would be something to address. But then let's say that it is true. Then what is the point of then putting that into compost or to land application? Aren't you just making things much, much worse? So Deb, do you have something to say about that?
Yeah, I'll add a little bit, and then I'll toss it over to the two guys here. So, we talked about how technology has really been improving. So some of these depackaging operations, these technologies are they don't smash plastics. They will open them up, if you will, to remove the food. So you'll still have dimensional plastics that are clean and can be recycled. Some of the technologies that might, break down the plastics into these shards or microplastics, unfortunately, that type of material, then the best place for that would be at a landfill, right? Because it would be a contamination in the composting operation, as well as in the wet AD. And when you talk about microplastics, you're not going to really be able to screen those out either. So, but let me ask John and Brian their experience with these microplastics.
I think Deb, I would just second your comment, which is we work very, very hard to make sure that we're not smashing the plastic, that we are squishing. If that distinction makes sense. So
it is a technical term. Yes.
It is it's like the yuck factor, right? But it's a huge goal of ours, especially as we're working on farm. We don't want to incorporate microplastics onto the farm.
Yeah.
Great. So sort of in Lynn's mind, a semi-corollary is PFAS. So are you, and Deb also, I know you're an expert on this topic, you might want to chime in as well. Are you testing for PFAS in the digestate and or for Brian in the end product? And are you finding it, and what are you doing about it? So Deb, I don't know if you wanted to give any sort of overarching observations here first.
Yeah, I'd be happy, to do overarching. So certainly, as we know, food packaging primarily, the paper-based and some of the waxed, food packaging types of materials, they do contain PFAS. So when we work with clients, when we work with facility owner operators, we would, suggest and recommend to, test for PFAS. And, we can conduct that a lab analysis and get the lab reports back to our clients. But, again, you have to go upstream and begin to talk to, who's providing you, the packaged food materials, and start to work up that value chain to see if you can get them to pivot away from these types of packaging. And that's, working with the consumer packaged goods manufacturers to get them to change.
Yeah, Lynn. Yeah, sure. So what I'll say is that we for PFAS and these PFOA chemicals, we have not seen them in our compost or our post-digestion substrates. And again, to John and to Deb's point prior, the technology that we deploy for depackaging is not a fine shred technology. It's a brute force, break the package open and not create confetti, but create bigger hunks of packaging. So that really is the first line of defense for making sure plastic doesn't end up in a compost stream. We also deploy some finer plastic screening technology ahead of the digestion system to make sure that we're really not getting anything into the compost blend, because we're hypersensitive about anything that's not nutrient driven or post digestion driven getting into our digestate products. So we've been testing vigorously on the solid side. The tests are evolving for the liquid side for PFAS. So we've been exploring some different testing strategies in some labs in the Northeast. But yeah, we're staying ahead of the curve, obviously keeping up with the conversations that are happening with the states and the EPA relative to testing for these PFAS compounds.
Yeah, and the only thing I would add to that is we're very careful. We don't handle any biosolids, so we take only animal manure and the food waste. And to date, we've not had detectable PFAS in any of the streams. And so I think that where it starts to get complicated is if you're working with wastewater treatment plants, if you're working with biosolids, those PFAS issues do start to really pop up. But if you stay to your lane, as it were, on the agricultural side, that's been our recipe for success for us.
Right.
And one last thing too, as we know, the PFAS chemicals are everywhere, and there are even reports that PFAS are present even in the food that we eat, not just in the packaging. So looking upstream on how to manage PFAS in our industrial and chemical processes is very important, and not necessarily just pushing the onus down, if you will, onto the solid waste or the organics infrastructure. It's really needing to look all the way up through the supply chain.
Great. So what sort of, and this would be for both Brian and John, what sort of pollution prevention permitting and strategies, air or water, are you required to do, and maybe any additional ones you do?
Since I know what Brian had to go through in Connecticut, I'll let him start, because that's some evil stuff down there.
Yeah, my answer might be a little bit longer than John's, so I appreciate it, John. Thank you. Running an industrial, commercial scale food waste digester really touches on 3 regulatory processes. Obviously, solid waste is the first and foremost. We're taking an outside waste and processing it on one central site. We're also, we had to seek a wastewater permit, because some of the water that we produce, we actually run a small wastewater nutrient recovery system on site. So in order to do that, we had to seek a permit for that. And then we have a combined heat and power system that generates electricity and has some air emissions. So we had to file for a new source review permit with the state of Connecticut. So those are really the 3 state permits. We asked a lot of the Connecticut DEP to permit really 3 processes into 1 permit, and being the first. Sometimes the pioneers charging the hill get shot, sometimes they make the hill. So we made the hill. We were very happy to make the hill, and here we are. So that was our regulatory story from a state perspective.
Yeah, and I think we can probably match that, having completed the first Vermont 248 permit series, which actually is, I think it's 13 sub permits, to have the first renewable natural gas generating system in Vermont that injects directly into the pipeline, where we are transporting our molecules to Middlebury College and Ben & Jerry's and a bunch of the other folks out there. And that was I think it was about 2 years worth of work, and it's not for the faint of heart. But these are highly regulated plants. We're an energy generator, we're a waste receiver, we've got air permits, water permits. We spend an inordinate amount of time and energy making sure that we do it the right way.
Yeah. Yep.
And somebody commented, and I hadn't noticed this myself, I have to say, that it looks as though the majority, if not all, of the facilities that you guys happen to show us snapshots of are in heavily wooded areas. Do you have setback or industrial location requirements associated with accomplishing this?
Well, there's not a requirement, but I think, and I can't speak for Brian, but I think both of us, we're looking to make sure that we can be good neighbors. If there's any issues on site, we're trying to make sure we're not directly contiguous to residential neighborhoods. Just from an odor standpoint, if that's what kills virtually every digester, composting facility, and depackaging facility in the United States is odor. So, we on our ORF, we've got a 15-ton activated carbon air management system, which is remarkable. I've never seen anything like it. So we are odor free at the side door. But that's, I think we, again, just want to err on the cautious side.
Yeah, and what I would add to that, Lynn, is the pictures that I probably showed probably are a little deceiving. Beyond the tree line, we have one of the United States oldest run theme parks as lake compounds. Which is about 150 yards to our northern border. So we do a very careful job, as John mentioned, of keeping our odorous processes behind closed doors, under negative air capture. And really our facility is sited in an industrial area, which if anyone is familiar with ESPN, we are a really strong 3-wood, for a golf analogy, away from ESPN. So we've got to be good neighbors. And as John mentioned, it's incumbent upon us as industry colleagues to make sure that we're showing what good representative digestion and organics recycling could be and should look like, quite frankly.
Right. So there's a lot of curiosity about things that you may or may not want to tell us. So, so feel free to say, what sort of brand equipment are you using? Why did you pick that brand? How much are you charging for tipping fees? Why is this cost competitive? And well, nobody has said this. You got to, this is an incredible business model, and how has it worked? So that was one.
I think for a small fee, Deb will tell you all of that.
Deb, okay.
Yeah, but I think you got to pay her first. I think Brian and I aren't going to talk about it. I think Brian said something like special sauce, and there's certainly a lot of special sauce. And not an insignificant amount of scar tissue, I think, in the trial by error. But I think if you hire Tetra Tech, they'll give you all of the goodies on that one. But,
we can figure that out for you. I
think the easiest answer is organic recycling is very hard. It is. There's been a lot of trial and error, and I know Brian shares a lot of the same scar tissue that we do. Both of us kind of knocking away at this for a very, very long time. But there are lots of different technology vendors in the States, lots of good ones. Most all of them come from a European start. So this all started in Germany and Denmark 20 years ago, or now actually 25 years ago. And so the genealogy on all American depackaging equipment is from kind of the German, Danish, and Italian. Interesting, I'm not sure exactly why those three, but those are where it kind of all started, and everything that we buy is some type of great grandchild of the original European systems. And then we all do our own cute little modifications and secret gym dandies to show it. And I was carefully scrutinizing the plumbing on Brian's as he went by, but I could tell he's as someone inside the trade, I could see as he panned onto the good stuff, it went dark.
Right out, gone. Yeah, and to John's point, I would add that there's a lot of wonderful technology that derived from overseas that is here domestically, and there's not a one-size-fits-all approach. These equipment, these processes are carefully deliberated and assembled in a fashion that meets the needs of the substrate, the customer, and quite frankly, the operation. So, what works for me and for John and for others likely and more realistically won't work for someone else who's in a different locale with different market pressures or externalities. But it's always incumbent upon us as we're doing our business to try to save our partners a couple bucks while we're doing, the right and good thing by the environment. And we know right now that, in a sidestepping fashion, answering the pricing question, particularly in our locale, prices for disposal are only rising for traditional disposal. And if we can offer a delta of savings to incentivize diversion and recycling, then that's a win-win for both parties.
Okay, thank you. So Deb, there were
higher Deb.
I'm sorry, John, go ahead.
Yeah, call Deb. Call Deb.
Deb, there was a couple of questions early on for you, and of course we got sort of swept up on these other things. One is just a very specific. Are you able, please, to repeat the tonnage related to food waste processing that you gave in your presentation. I realize that's like an hour ago, so maybe not. But if that's a factoid you're able to bring back up, there was a question about that.
What on the EPA facts that I
think
presented
so.
a little earlier?
So. Yep. Yep.
Yeah, you know.
Well,
So,
we can come back to it. That'll be your secret question. That'll be your final exam question.
okay.
And a couple of people reacted to what they thought they heard you say. So let's clarify. Did you say that compostable packaging is contamination?
I did because any type of packaging is going to go through the depackager, and it's going to be separated from the food waste. So in essence, packaging waste would be considered contamination for the food waste. And let's look at one scenario. So if you're looking at a wet anaerobic digestion process, compostable products or materials are not necessarily going to, if you will, biodegrade in the AD process, primarily because of temperature, and I would believe because of the microbes present really don't metabolize the compostable feedstocks.
And time.
In time, yeah.
It's you know, we only hold the material for a month.
So the retention time is not long enough.
Correct.
Right.
Correct.
Right. If for any reason that you had enough of material coming into your depackaging facility and you knew for certain that it was all compostable, all of that material could be set to the aside and get blended into, let's say, you know, a composting windrow or an ASP to be, you know, managed that way. So you've got these, you know, these couple of options. So really, just to go back to answer the question, all packaging would be considered contamination.
Yeah, we only have actually 2 compost barns. So we take our compostable fraction and either use it as bedding material for our animals, or we give it to composters. We only have 2 composters who are willing to take compostable bags at the moment. Yep. And I don't know, Brian probably has a much better insight into their process.
Yeah, it's a great point. So, you know, compostable products, whether they're bags or hardware or compostable silverware, if you will, or usable compostable products, don't do tremendously well in an anaerobic environment. You know, we're screening a lot of them out, or in a lot of cases, they're being refined out through the process. So what we will do is when we can capture them, we will finish compost them, whether it's a bag or if it's a piece of compostable ware in an aerobic process. They do much better aerobically after they've been downsized or volume reduced to be more exposed to anaerobic environments. So yeah, but to your point, John, and to Deb's point, you know, definitely a part of the waste story that's evolving, and certainly recognize that compostable products are a very useful tool in the diversion hierarchy, and one that we don't avoid, but are definitely evolving our thought process on how best to manage.
Yeah.
So does it matter if they're certified compostable, or it just doesn't matter? Doesn't matter.
Doesn't matter.
Yeah, it doesn't matter.
I mean, they're compostable as compared to original plastics from a geologic time frame.
Yeah.
But in the time frame that your modern compost facilities are turning their windrows, they're just very seldom. And again, as I said, we only have 2 composters in all of New England that we work with that actually will take the bags. And those are guys who are actually turning their windrows 6 or 7 times, which is well outside of the norm of most management systems. So I think it's really, as Brian said, the compostable utensils bags are still, there's a lot of distance they need to travel before they become really quickly compostable. They're more long-term compostable.
Yeah. So if I can just maybe talk a little bit more about compostables and then move on. Yeah. So Lynn, it is important for compostable materials to be certified by the BPI or other types of certifying bodies like maybe Cedar Grove or the Composter Manufacturers Alliance, and then there's a couple of European certification labels. But primarily in North America, we're familiar with the BPI certification. And when a public or a private entity makes a purchase for compostable bags or any sort of compostable food service or package, it really should be BPI certified. And they will work overtime in composting. The certified or the Compost Manufacturers Alliance, they actually test compostable products in various composting sites around the country. And there is a lot of variability as far as temperature and moisture and the operation of a composting facility that has an impact on how quickly these compostable products will completely compost and biodegrade. But they do work. Sometimes, though, they take a lot longer than you think that they will. I mean, that's an area that when I first started working in the organics field, I worked for a biopolymer company and took a lot of hits, did a lot of research, did a lot of field research. And, you know, it really does help pivot our solid waste in reducing the use of single use. But yeah, we just have to we have to bear with it and look for opportunities to use certified compostables.
Right.
Yeah,
Now,
and Lynn, if I may make just one more point on you know, where this will likely end up is as states and regions start to develop more definitive compost standards. You know, we're going to start to see this I don't want to say pushback, but this market sensitivity around certified compostable plastics. And having spent a lot of time in Europe, particularly in Italy, where there's some good groups like Novamont out there who produce, you know, a high grade compostable plastic from a matter B derivative. This is sort of coming down the pipeline, if you will. So when we get the question about compostable plastics, you know, we're trying to and quickly to point to some of those plastics, some of those polymers that are certified, do well in anaerobic or aerobic processes, so on and so forth. So.
Great, that's great. And one of our audience members, who I happen to know is in a commercial composting operation, notes that there is a lot of research in this arena for anaerobic digestion, and that she said that a new program for well, she's got this great shorthand here, but I'll say anaerobic digestible plastics has been developed in Europe. So you all noted that our technology is European, so maybe we can anticipate seeing some of that additional technology migrating here.
We're crossing our fingers.
Yeah,
we would
one could hope.
Yeah, we would love it. I mean, for us, this is you know, it's a real issue for us, and we'd love to be able to utilize all of that great carbon in our systems.
Yeah.
Wonderful.
Yeah.
So
what was that first
yes,
question?
Go ahead.
What was that first question on tonnage?
Percent, yeah, the tonnage. I think they were asking probably about the proportion of the solid waste stream that's organics.
Well, if you look at the amount of MSW generation, the combination of food waste and yard debris is a total of I think 33.7%, and food waste is 21.6% of that. But as John said, there's more organics that really isn't in the EPA pie, you know, that really we believe that brings that number up to almost 40% of the MSW stream. But what I showed today was, you know, from the EPA report. Also, what's interesting, as I mentioned, starting in 2018, the EPA is now also reporting other food management pathways other than, you know, composting, and it does include the food donation, the animal feed, and you know, co-digestion with wet AD. And so, you know, this opens up pre-processing so that food waste can be processed and managed so that it can go to these different types of operations, albeit, you know, food donation is exactly what that is, but, you know, food needs to also be pre-processed for animal feed, as well as anaerobic digestion. And, you know, particle size reduction, of course, you know, is necessary for some composting operations.
Great.
So go ahead.
I keep cutting you off, and I don't mean to, Deb. Finish your thought, please.
No, that's good. These are great questions.
So a
Go
lot of
ahead.
our audience is outside of New England, and they're clearly jealous about what you guys are talking about.
We're coming. We're coming. We're on our way.
We're getting questions
Don't
from all over the United
worry.
States here. I mean, are you here? Are you coming here? Who is here? What sort of partnership opportunities might there be? First of all, I'm going to share everybody's questions with the speakers. And so I think some of these they'll definitely want to be following up with individuals. But is this a New England phenomenon, or do we see this as a national business profile?
No, and I'll jump in, and Brian can drop the bomb. So we actually just at the end of last year announced the Farm Power Strategic Alliance, where we've partnered up with the first founding 3 members are Unilever, Starbucks, and the Dairy Farms America, where we are looking to work with farmers across the United States and food waste generators across the United States. And we currently have, I think at last count, and I'm going to be out of date, but about 83 farms across the United States where we've signed agreements to build anaerobic digesters on their facilities. And so our hope is that this really becomes an American phenomenon, and that we're able to do it throughout the United States. There really isn't any, there were some limitations when we started, and certainly New England has been much more aggressive from a regulatory standpoint to drive food waste out of landfills and incinerators from the organics bans. And I think as Deb had in her slide, but this is now something where instead of it being a regulatory driver, I think it's really an ESG driver. So more and more, as folks are looking to meet their commitments on renewability, on decarbonization, food waste becomes a very powerful tool for them. And so we're super excited about that.
Yeah, I think John hit it right on the head. I think what has supercharged the anaerobic digestion conversation is this concept that we can make a decarbonized fuel from the biogas we produce called renewable natural gas, which has a carbon intensity that is markedly lower than traditional natural gas. No longer is digestion just nouveau in Northeast or on the West Coast. Renewable natural gas is being considered and produced on farms of the Midwest at wastewater plants along the South. And obviously, the Northeast and California is where a lot of this development is occurring. But, much like John, because of the tentacles of our business, we stretch from Maine all the way down to Florida relative to our operations, and obviously we get a lot of knocks at the door for folks considering digester installations in the Southwest and the West Coast, and we've prepared and certainly have cut our teeth on this facility and are preparing to bring that knowledge to other facilities outside of the Northeast as well as Northeast proper. So
that's great. So how critical is it for either of depackaging business models to succeed, for there to be state energy policies or incentives that underlie it?
Yeah, and I think that's to Brian's point. That was a big part of where we started, and certainly both Connecticut and Massachusetts have had a very successful net metering regimes where they were allowed to sell the power back at a retail rate rather than the wholesale provider rate, which allowed the systems to be economic. It's very expensive to build digesters and very expensive to operate them. So we need to be able to sell power at a reasonable commercial rate. That isn't the case in most of the US. So the biogas to renewable electricity was always a fairly limited application for food waste recycling. That has changed pretty significantly as we've gone to food waste to renewable natural gas, because that renewable natural gas flows much more easily, and it also is a really critical decarbonization tool for utilities and local distribution companies. So it's still early days. Local regulatory help is hugely beneficial. Or state regulatory, all as I'm sure everyone is painfully aware of, no more so than all of us on the panel, there is no such thing as a federal energy policy. So we don't have mandated federal energy guidelines. So we have to work state by state. But the solar industry and the wind industry have kind of beat that back and have figured out how to do it. And so we're doing the same thing.
Either Deb or Brian want to add to that?
Yeah, I'd say to put the punctuation mark on it, we're very optimistic about the capabilities of renewable natural gas as a decarbonized fuel, and it's sort of expanded the playing field, if you will, and unbuckled the reliance on state energy policy. Now, as utilities seek to decarbonize their fueling footprint, they're seeking the support and help of folks like Vanguard and Quantum to go out there and produce decarbonized fuels. And in doing so, 5 years ago, we were heavily dependent on state energy policy. Now, if there's an attractive state energy policy, it certainly is great, but we're not going to live and die on the development side based on what the states are doing. So part of the nuance of living in the United States, we have 50 states that have separate energy policies and waste policies, and with the uptake of renewable natural gas, it has certainly sort of added to the playing field for digestion, given us much needed parity, if you will, to our brethren, other renewable energy brethren, with solar and wind and other sorts of renewable energy commodities. So yeah, we're excited about the RNG piece, as I know John is as well.
That's fascinating.
And we play a role in that as well, working with our AD clients and our wastewater and even our landfill clients, where we can help convert gas, clean it up, and convert that to fuels. We have a biogas RNG technology that can actually be a bolt-on solution to some of these operations and facilities to help clean up the gas and get that into for vehicle fuel. Yeah,
that's great. So we're just about out of time, and I have barely touched on the questions. I mean, barely touched on the questions. So first of all, before I ask the last couple of questions, which I'm going to, I do want to thank our audience and apologize to those people who have been posting questions and are probably really annoyed with me at this moment. So
we'll come back next week. It's okay.
One question.
Same time, same place.
Let's go. So are you guys aware of any, I'll say partnership, but that isn't the word the questioner asked, but I guess pairings of MRFs and depackaging operations? Early on in the presentations, it became a seemingly, I mean, I agree, it was apparent that, well, if this stuff is contamination at a MRF and it's not contamination with you guys, shouldn't you be working collaboratively? So are there examples of that?
Yeah, I think in California, is it CRRC? There's one MRF and ORF kind of co-located.
I'm sorry, where did you say that is?
Just outside of Los Angeles.
Los Angeles,
I think the company is CRRC. But they have done a co-location between the two. I think it'll become more and more mainstream as things evolve, and certainly Brian's Eco Park, I think, is a brilliant example of how you can start. And each one of us, what's so intriguing about organic waste is that you can use it in so many different ways. And there's a remarkable company in California called Mango Materials, which is trying to use anaerobic digestion to create bioplastics from food waste. So there's we're really, as someone who's been doing it for now almost 8 years, we're just on day one of what the potential is for organic materials in the repurposing and recycling markets.
Oh, that's inspirational, John. Thank you.
Yeah.
Brian, any last comments?
I think John said it well. We're not even in the first inning of the organic story. Apart from reusing biogas, there's also some wonderful research coming out of kind of the UK and Europe about graphene production from biogas and methane substrates. Graphene being a substance 50 times stronger than steel, but as flexible as traditional plastic, derived from methane from biogas. So yes, getting back to the MRF comment. I think as more diversion needs sort of develop here over time in the United States, we'll see more of these organics recycling pairings with MRFs co-located at transfer stations, maybe at municipal assets. Again, it's not a one-size-fits-all approach. It'll very much largely be between public and private partnerships and in areas and pockets of need to really decentralize the waste stream, targeting specifically on the recoverable fraction of our waste, which, as we're all here today to talk about, is food waste.
Great.
Right.
So a participant tells us Anaheim Republic, Murph. Yeah.
That's
Yes.
There you go.
Deb,
Okay.
did you want to say something?
Yeah, no, I just wanted to echo that, in my opening slides, talking about the co-location of these operations at a MRF or a transfer facilities. And certainly if anybody, in the audience who wants to explore that, again, that's the type of, analysis or feasibility study that Tetra Tech can offer.
Great. Thank you, everybody. So I'm really sorry, out of time. And so, but here's what I want to say to our audience. The recording will be posted by this evening. The PowerPoint presentations will be posted by this evening. We're getting several questions about how they can contact you. First, I'm going to send all these questions to you guys and you can reach out to them, but the contact information is in their PowerPoint presentations. The presenters have been beyond outstanding. I mean, you guys were just phenomenal. Thank you. So I had a blast. Thank you. This was just great. I also want to recognize and thank Vanguard Renewables and ADS as being sponsors, which is great. And most of you probably realize there are more NERC webinars coming up, including some next week. And you can find out about those on our homepage. So with that, again, thank you so much, everybody, and have a wonderful balance of your day. Take care. Bye-bye,
Thank you.
everybody.
Thanks, Ryan. Thank you.
Thanks, everybody. Thanks, guys. Bye.
Bye-bye.